As a preliminary evaluation for planning Arduino control projects, I thought of looking at the output voltages and currents available from Arduino Nano. Digital output pins of Arduino Nano provide 5 volt output in high state and 0 volt in the low state. You may remember my old post in which I used an example sketch to make the built-in blinking LED on the Arduino Nano to blink at varying speeds. The LED will light up in the high state and go off in the low state. Maximum output current mentioned is 40 milliamperes, but it will be safer to use only 20 milliampere to avoid damage to the ATmega328 chip inside the Arduino Nano. Hence, if you are connecting an external LED to the Arduino output pin, use a current limiting resistor. Otherwise, excess current draw can damage the chip and or the LED. LEDs do not need 5 volt to glow, though there is some difference between different colors of LEDs. 5 volt pin on the Arduino Nano board can provide up to 500 milliamperes. But this is the combined power supply for the board itself and other low power components. Total current draw of all Arduino I/O pins combined is 200 milliamperes. I am checking the outputs from my Arduino Nano board. The board has been powered using a power bank. This is the power bank which I am using. And then I will check the pins. This wire here is the jumper wire is connected to this 3.3 volt pin, and this black wire is connected to the ground pin. You can see the ground pin here through the breadboard. Now we will see what the voltage is. I have connected both to the multimeter using crocodile clips. Meanwhile, the power bank has gone auto power off. I will switch it on. Now the power bank has been switched on. You can see the light blinking on the power bank, and with the power bank switched on, the output at the 3.3 volt terminal is 3.31. That's acceptable. I have connected to the 5 volt pin. You can see 5 volt pin, and LEDs are blinking very weakly. That is because the power bank has gone for auto power off. We will switch on. Now it is on, and you can see that the output measured from the 5 volt pin is 5.02 volt. So that's also acceptable. Now here you can see two LEDs. One is power LED which is continuously lit, and there is a L LED which is blinking. That blinking speed can be adjusted using the Arduino sketch. Again, auto power off of the power bank. Now I have connected to pin number 13. This is pin number 13, and the other is to ground. You can see the LED is blinking, and when the LED is blinking, the output voltages, you can see maximum it goes up to 5. That is when the LED is on. In the on state it goes nearly to 5, 4.9 something. And when LED is off, you can see that it goes down to nearly 0. Now I have connected a blue LED to the D13 output pin using a 330 ohms. Again, power bank auto timeout. Connected a blue LED to the output pin D13 using a 330 ohms resistor. You can see the resistor here. This is a 330 ohm resistor. Now the external LED is blinking along with the internal built-in LED. That's because according to the blinking time, it will provide an output at the digital pin 13. Now I am measuring the output, the current. I have set it in the 20 milliampere range in this multimeter it is 20 milliampere range, and you can see that when the LED is lit it goes up to 5.4 milliamperes, and when it is off it comes down. Because it is a rather rapid change every second, it is difficult to measure the exact value. Again, there was again auto power off. Almost 5.5 volt, sorry, 5.5 milliamperes of current is shown here. Instead of the 330 ohms resistor, I have switched over to 220 ohm resistor. You can see that the current drawn is a little more, nearly 6.8. That is the current drawn. That is because the resistor in series is of a lower value, 220 ohms. So this is a safe value because the recommended is below 20 milliamperes. Now this is drawing only 6.8 or rather 7 milliamperes. That's safe for the Arduino board.